I've been doing a lot of research, and this is going to kind of glove in with Bill's presentation that he has. Recently, they had a sale on Family Tree DNA for the subgroup U106. And I'll explain to that if you don't know what that is. We'll get to that. But there's, if you look on there, there's these things called SNPs. They call them SNPs. Stands for something polynuclear, single nucleotide polymorphism. Okay, you don't have to remember that part. They just call them SNPs. But what this does is that the way that they look at it, it will help tell you exactly, kind of where you came and how you developed. And that I ordered this test, and you've got 100 SNPs under the U106, and this is what came out. Is the subgroup R. That's what all the Ganns are, R1b. And it went way down to this Z154, and I'm going to try and explain that to you and tell you a little bit of the significance of what that means. Okay, what? All right, haplogroups. I'm just going to kind of read this, and we'll go through this real easy. A haplogroup is a major branch of either the maternal or paternal tree, that is if you do the maternal DNA or the Y DNA. Okay? The maternal DNA is using the mitochondrial DNA. That's different part. That shows the mothers. Another way you go with the Y is the father. All right. Haplogroups are associated with early human migrations. So today they can be associated with a geographic region or regions. So that's underline geographic, because that's where we get the interesting part. Next, please. So Ganns in the U.S. are descendants of Samuel Gann, are members of the R1b haplogroup. The majority of Europeans are members of this haplogroup. Something about 40, I believe 45%, at least one of the recent ones I saw. Now you may have noticed on Family Tree DNA, if you ever been to the Gann Project page there, it lists, and Bill has up on the board, he's got a big listing back there, and it has the haplogroup listed right before it starts all the results of all the alleles. Both of these statements are true. Let's see, I didn't read that part. You may have noticed, that the Family Tree DNA page that shows M269 is what it says out. And that's a major branch of the R1b. Now we're talking about R1b is the haplogroup, and they have smaller groups under that, smaller groups under that, smaller groups under that. It keeps going. They call them subclades, is the definition of that. So M269, so if you see anybody that's not M269, if it says I or M, they're not connected with us. All right? So next, please. So here's the picture right here. Right up here, you have somebody that's IA7729. So they're not in our group. Here's another R, but it's PF2028, I think. But all the rest of these you can see are the 269 until you get down here to me. I did the Z154 because it's just a little, it's farther down the line is where you get the test done. Next, please. So a subclade is the subgrouping in the haplotype groups of human genetic trees. They call it phylotrees or phylogenetic trees. This may be either the Y chromosome tree or the mitochondrial tree, or your maternal side. Subclades are more specific to a location or a population group than the major branches, haplogroups. Think of a small tribe of related people within a nation. Now this is a really interesting chart. If you look right here, you see R1b. And as it spreads and goes eastward, it's gonna change into different big groups. And So you see R1b, and they moving eastward right here till they get over here. You see U106, so which is one of the major branches of R1b. Now we're going to go further than the U106. There's several steps down, even below that I'm going to be talking about today. So when subclade testing has been performed, we find that we are members of another group called U106. Here's the next one's a map of what U106 in Europe looks like. So see the distribution? So it's really thick, all right in here along the coast lines, and in England. We're the U106. All right, next. So you see the highest densities in Belgium, northern Germany, Denmark, southern Sweden, southern Norway, and England. The most recent testing shows that from S21 is an equivalent to U106. Some places they have different terminology. I think S21 is an older terminology, and U106 is a newer, more specific term. Now under U106, we're down, the next level is Z381. Below the Z381, we're in Z301. And below that is a couple more subtypes, but then you finally get to Z154. So it's very, very, very specific. Next. So here's the tree. This is the U106 tree. These are the major branches of the U106. We fall under the Z381. As you come down to Z381, these are the three main branches of that one. And I stuck this one over here because there's little groups that don't fall under each three of these. And this is where ours lies, in this FGC 8512. Some of these are so new, they have the test for them, but they haven't developed the phylogenetic tree yet for them, because they've been making advances in DNA faster than they keep up. And there's a reference, the International Society of Genealogists, ISOGG. This is where that came from. So next, please. All right, so we're getting even more specific here. This is showing kind of, once again, the U106. This is putting it on a timeline. I know this is hard to see. I can email you a copy of this if you want. You can blow it up to see it a little bit better. This says 25 BC right here. Let's see. This is 1500 BC. 1000 BC. Right here. So U106, we fall under the Z381, we're under the Z301, and then there's a little bitty one right here, Z155, and Z154 is a subgroup under Z155. So we are a very, very specific, small part of that R1b, which is very, very interesting, because being that select small group, we could be easier to be found when you start testing the population. All right, next. Now this is a really busy slide, but all of this, back up one. All right, see these 381, this is what that wheel is going to be showing. Next. All of this is people that are in Z381. This part right here is the subgroup of Z301. And then down here, this one little stripe right here is where we fall. Okay, next. Okay, so when we start doing the genetics and the genealogy and start putting those together, that's where the interesting parts happen. So we're going to find out, the Jutes, the Angles, the Saxons, the Frisians, all from these parts where they came over, because these were the tribes. We fall under, the U106 is a group of Proto-Germanic tribes. So the early Germans. where they settled this area and then moved over. Next slide. This is an area of Kent, and South Saxony, West Saxony, East Saxony. Right up in here is the area of Whitestable.
Whitstable.
Whitstable?
That's what they say.
Okay. I'm not sure. On up north, on this side is Lincolnshire. So you see that the Jutes were predominant in this area and the Saxons surrounding them. So next. So this is the interesting part. Right now the DNA is so, testing is so far ahead of the sociologists, the archaeologists, the paleontologists, all those people who are doing the research that eventually we'll be able to match up our genetics with history, and we'll be able to track back and see where our early tribes. I mean, we're trying. I know right now we're just trying to get back to who came to America, but this is going to go way farther back than that. Next. So in Joy's book, she talked a lot about the early parts, and we're seeing the exact matchup of what she was writing about. That Flanders area was the northern part of Belgium. We see them in England, and Lancashire and Kent areas. Okay. So I think it's going to be very interesting what we're going to see in the future, and I think if we get a hold of some of these researchers, we can present them and say, hey, we're a group of very specific people, and we've already been tested. You should look for us and help us do our research. You could do a paper on us or something. It might be a good way to get some more research done. All right, that's all I have on that. Does anybody have questions?
Which test did you do your results?
Through the family tree DNA. It was, I think they did 100 SNPs for maybe $99, which is a bargain because each one is like $40. And this is how I came out to that. I had already worked out, I was at Z381 on my own. I just did tested this, tested that, and then they came out with this
Was this test separate? Was this separate from the regular 67 or the?
Right.
Okay.
Right. And it's
What, did you know what they call it?
the particular test.
Wiggler.
Right. It was a sale that they were running.
Yeah, just.
It's a
test
snip
It was a specific,
package.
right, specifically for people, for U106. It was they were looking to see the further breakdown of that. Because there's so many that are under R1B, is they're having to kind of go past the R1B and see how, okay, we need to look more specifically to be able to see all the different people. Because if you start looking on the computer, and I have looked, believe me, you'll see House of Bourbon, we've got Kings that are Z381. It gets pretty interesting, but I have looked and looked and looked, and you don't find anything on Z154, except for one or two people that have been looking and asking on forums and say, hey, I'm Z1, what does that mean? So it's yet really to be anybody publishing any data on it. So it's kind of a wait and see at this moment, but it's exciting. Any other questions?
You ever come across an RM420?
RM420. I'd have to go back and look at the phyllo tree because that's higher up. That's I think going to be analogous to the 269, so it's farther up the chain, but it's going to be different. It's going to be at the same level, but it's going to be a different chain, I believe. I did a comparison. I wrote a little. Basically, I just gathered a lot of information from family tree DNA, and I did a little thing on how to interpret your tests. They have published tables in there that will let you look at, okay, well, if I did a 37 marker test and I am 3 genetic deviations or 3 markers away from Bill, you know, how closely are we related? And it will give you a percentage looking, because it's all math, how far back, you know, at 50% possibility, maybe, you know, let's say, well, 6 generations back. And then at 90%, it may be 8 generations back. But it gives you some information like that, so you're able to see how closely you're related to that person. The more markers that you do, the bigger the math area that you're looking at, and you get a greater specificity into the results, because you get more math. I read a book about a fellow that was looking for his adopted family, or he was adopted, and he's looking for his birth parent. And this was years ago. He did a genetic test to figure out which. He was looking at which brothers. There's a group of 4 brothers, of which one was his daddy. And the test that they did back then only had 8 markers that it tested. And so he thought, well, this guy's my dad, because he came up, on the 8 markers as being the one. But then years later, they've got millions of markers now that they checked. He went back and redid it, and that guy wasn't his daddy after all. It was one of the other brothers. So the more markers that you get, the more specificity, to be able to check and do the math, because it's a lot of that interpretation is all math and statistics. Because they're looking at a finite number of variables and trying to make a way to look at all of them and compare them.
Now, on my GED match, there's a column that says is R something. I don't think it says that one and everything. So what do you do with that once you get it? Is that people that you should test further?
That's looking at it a different way. What we're doing on the family tree DNA is the Y. I'm talking about the Y DNA, and that's probably using the autosomal. So that's looking at it from a different way. Instead of just looking at the Y, where that you have the same father, the same, you track back the line of the father, you're looking at all of the ancestors. And you may get a little bit here, a little bit there, a little bit there, and you can go back to about 6 generations, and then the percentages started getting so small that it's hard to tell exactly which person you got something from. Because if you go back 6 generations and start thinking of how many grandparents there are, I've never looked at it, but that's a bunch. I'm not great on math, so I guess you can tell. I'm from Alabama, so I have to take off my shoes.
But it's accurate.
But
so it doesn't
one of the
mean
interesting
anything when
things,
you're looking at it. So it doesn't, for me, it wouldn't mean anything then.
right? No, I think
128.
128.
Yeah.
One of the interesting things that I noticed on the GED match that you can do is when you run the different ways of looking at it, is it will print out all of your chromosomes, and then it will break down the percentage, like, okay, how much of it is Northern European, how much is Central European, how much is, and on mine, I had on about 4 different chromosomes, I had 3 or 4% American Indian, which it's like, okay, somebody's back there somewhere, but I don't know who. But it tells you each and every chromosome will break down that percentage. So you'll see, you can almost see then, if you know your tree and where they came from, you can almost tell how much of that person you might have in you. Pretty interesting. All right, well, who's next? Oh, sir?
Can you have something summary like this related to the Gann Haplogroup in the Gazette, so we can get a better feel for what we're looking at?
I've already submitted this article.
Okay, good.
It's in the queue.
Yeah, we had too much material this past month, which is kind of unusual. I guess it's either drought or flood.
That's it.
It was flood this past month.